So for Wednesday's lesson, we're starting out at what is at the top of labeled page 43, where it says, what is a residual? Okay. So a residual tells us the distance between what we predicted with a regression line and then what was actually observed. So the actual prediction, or actual minus the prediction. Okay. So residual comes from the Greek word leftover. So what's left over from the predicted line, the regression line that we found or will find here in a second, versus what we actually observed. Okay. So in symbols, we have y minus y hat. I also want you to think of the abbreviation AP. So actual minus predicted. Okay, in order to find this, the residual, you have to find what's predicted based off of the regression line, and then you'll be given like what was actually found or what was actually observed in this situation. So in our tapping on cans example, we were given this equation for our regression line. So we can predict how much would be at 4 seconds, and that would be our explanatory variable, so x equals 4. But then this is what actually happened. Someone actually took a can of soda, shook it up, tapped on the lid for 4 seconds, and then after it exploded, they measured 260 milliliters of soda. Okay, so in order to find and interpret the residual, we first have to find the predicted. Okay, so the soda amount that is predicted, so soda hat, equals to 248.6 times the tapping time of 4 seconds. That's 259.92. Our residual equal to the actual amount of soda minus what we predicted. So we actually had 260 milliliters, and we're going to subtract the predicted amount. The other thing about these residuals is that they do tell whether you're above or below the predicted value. So since 0.88 is above, or is positive, it's above the expected. Okay, we need to interpret this. So we calculated, now we need to interpret in context. The residual tells us that we were 0.88 milliliters above what we had predicted. We had 0.88 milliliters more than expected left in the can after tapping for 4 seconds. Okay, put it in context, tell what the explanatory variable you were given, and make sure you have your units on there. From those residuals, we can find our least squared regression line. Okay. There's no spot on your notes to like put this in, but I would definitely put in what the least squared regression line is. So think about how we found standard deviation, and our deviation by itself all added up to 0. So squaring that or doing any math with that wouldn't work. Same thing with our residuals. If we added up all of our residuals from every data point, it would equal 0. To combat that, we square each residual, and our goal is to get the smallest possible squared results, and that gives us our least squared regression line. Okay. We could do this by hand. We're going to kind of walk through it, but then I'll show you how to do it in your calculator. So we've got 9 sandwiches from McDonald's. They're all beef sandwiches. We think that the carbs affect how many grams of fat are in that sandwich. That's why our X is our carbs. So our carbs explain our fat. Okay, so with carbs down here, I had Desmond graph this for us. We're going to hold tight on A and B and come back to that Friday morning. We're going to do some stuff on our Chromebooks to look at that. But we're going to calculate the equation using technology. Okay, remember this huge long formula is on your formula sheet, but you don't need to use it. We've got our calculator, and on page 171 through 172, it will tell you step by step how to do that. Real quick, I'm going to walk through it. Pause this video as you need. So on our calculator, we're going to type in, or we're going to go Stat Edit to bring up list 1 and list 2. In list 1 and list 2, put your X's in list 1, put your Y's in list 2. Pause the video, type those in. Once you have those typed in, you're going to go to Stat Calc. And we want to go down to number 8 where it says linear regression in the equation form that we're going to use. So A plus BX, A being the y-intercept, B being the slope. Make sure your list 1 has your X's in it, your list 2 has your Y's in it. Leave the frequency list blank, and in store reg equation. So where do we want to store this linear regression equation? We want to store it in Y1 so then we can plot it later on. So to tell it to put it in Y1, you go vars, Y vars, enter, enter. So vars, over to the right one, enter, enter. And then we can have it calculate it for us. So that tells us our y-intercept is negative 40.2. Our slope is 1.71. So let's go ahead and write that down on our notes. And let's put it in context. So we're predicting the amount of fat. So we're going to have fat hat equals negative 40.2, our y-intercept, plus our slope of 1.71 times the amount of carbs that we have. Okay, it's important we're not putting y hat and x. We're putting fat hat and carbs. Okay? And that's what it means by define the variables. Fat hat, carbs. To have our calculator graph it on a scatter plot for us, go to your y equals, and you should already have that equation in there, and it's more exact than what we even need. Okay. Make sure plot 1 is highlighted. So right here, you can hit enter and it'll unhighlight it, or enter again and it should highlight it. Instead of jumping to graph, because that'll go by like a 10 by 10 graph, and most of our data is without, or not within that 10 by 10 graph, we're going to go zoom, and then we want to go down to number 9, zoom stat. Hit enter. And not only does it plot the points, it also plots your regression line. Okay, so let's sketch that on your notes. Okay, so this is the part in the book. Pause it if you need. Walk through those steps. Like we did last class, we're going to interpret our slope and our y-intercepts. So the slope, which was b equals 1.72, tells us, pause the video, try to interpret that on your own. And do the same thing with the y-intercepts. What does a equals negative 40.2 tell us? Is it reasonable in this case? Your answer doesn't have to be exactly like this, but it does need to include a couple of things. So it needs to include the slope, so mention the slope. It has to have this word predicted. We don't know the exact amount we are predicting, and we need to tell us that it's going to increase for every 1 carb. And our slope, it's positive, so we're rising 1.71, running 1. Okay, for your y-intercept, you need to tell me what your y-intercept is. Predict it again in fat if there were 0 grams of carbs. Since we can't have negative 40 grams of fat, you need to mention that it is unrealistic. If it is realistic, you don't need to mention anything, just if it's unrealistic. Okay, now we're going to calculate and interpret a residual for the Big Mac, which has 45 grams of carbs and 29 grams of fat. So in order to find the residual, you need to find the predicted amount. So we use our equation that our calculator told us. Fat hat equals 40.2 slope plus our y-intercept plus our slope 1.7128, where 1.71 is fine, times how many carbs we have. So our predicted amount of fat in our Big Mac would be 36.876. Okay, our residual, think AP, so actual amount of fat, which is 29 grams, minus our predicted. Actual minus predicted gives us a residual of negative 7.876. And then interpret. So we calculated the residual, interpret it in context. Tell me something about the amount of grams of fat is 7.876 grams less than expected based on their amount of carbs. Okay, so if this was like a Frappy, I would be looking for a couple of things. I would be looking for your notation with your predicted amount, your residual, and interpreting it in context. Tell me what the difference is, if it's increase or greater than or less than, and then what is expected based on your explanatory variable.